You will age slower driving the freeways of southern Louisiana than walking the trails of Colorado. This sounds like a riddle, but it's a matter of physics. We once thought of Einstein's theories of relativity on grander scales. In famous 1970s trials, scientists demonstrated them by putting synchronized atomic clocks on jets and comparing the time on each clock with a reference clock on the ground. Other researchers have bounced radar off other planets, and some still favor staggeringly complex math, but the essential theory behind these experiments is the same. Relative gravity and speed affect the passage of time. Specifically, relative to someone at rest, time slows at higher velocities, and it speeds up as gravity weakens relative to someone deeper in the gravity well. In a 2010 science report, the National Institute of Standards and Technology sought to bring that notion more down to earth. They used atomic clocks so precise they lose less than a second every 3 billion years. They tested both the general theory of relativity, which predicts time speeds up for objects in weaker gravity, and the special theory of relativity, which says that time slows for objects in motion. For the first, the NIST researchers raised one clock about a foot above another, making its gravity slightly lower, and recorded a tiny boost in time. For the second, in lieu of traveling at high speeds, they compelled a normally motionless ion in the clock to gyrate at speeds up to 22 miles per hour. They then recorded a tiny slowdown in time, owing to the clock's increase in velocity. And that brings us back to aging. Traversing Louisiana's higher gravity low altitudes in a sports car theoretically slows down time, while tranquil walks on Colorado's elevated paths will tick you through life ever so slightly faster. An even more real-life example? Whether you walk or drive, if you use GPS, you're helping prove relativity. GPS satellites must compensate for both their orbital velocity and the weaker Earth gravity from their position high above our planet. Otherwise, they wouldn't give accurate positions at all. The NIST researchers didn't intend their experiment to compete with more precise measurements, but they show how relativity's time dilation can apply on a human scale. And they help explain why testing Einstein's theory is a favored pastime of physicists and astronomers, with several challenges turning up in science headlines every year.